today we're gonna cover how to mill with the SRM-20 machine using the toolpaths generated by CopperCAM that you can check out how to do that in this other video. And the interesting part about this one is going to be you're going to use not just the milling bits but also drills. So these ones. So we have different sizes of drills. So we have 0.8 millimeter ones for drilling holes for vias, so in case you need to make double-sided boards. Then we have 1 millimeter ones for milling holes in circuit boards where the through-hole headers have to be attached, and then we have 1.5 millimeter ones that you should use for the bigger vias. So when you want to attach a header from both sides of the circuit board, let's say you're making one single side circuit board and you want to be the headers on top of it, but you need to solder them from the other side, so you need a rivet that actually goes through the circuit board and allows you to solder from the other side. Then we have we can use 2 millimeter drilling holes for different mounting holes. So mounting holes usually are 1 to 2 millimeters, and then 3 millimeter drills you can use for alignment pins if you need to drill a double-sided board. So this is the machine that we're gonna use. So it's turned on at the moment. I think that before I can use it, I need to close the lid, and it's gonna start to move to find its mechanical origins. And from here on, I can start using the controller application of the SRM-20. So the user interface for it, which is called vPanel, you can find it on the desktop of the computer that is connected to the machine. This one. I'm gonna move it aside like this. And with this machine, you can move the spindle, move the tool around along X and Y and Z axes. The cursor step option controls the way it moves. So with continuous, you can press and hold one of these buttons and it's just going to keep moving. With these times 100, times 10 and times 1 settings, you can move it 100 steps, 10 steps, or 1 step forward. And these match to hundredths of a millimeter. So 100 hundredths of a millimeter is a millimeter. So this is going to move your tool by 1 millimeter. Then this is going to move 1/10 of a millimeter. And this is going to move 1/100th of a millimeter. So this gives you an impression of what is the precision of the machine, but according to the documentation, it can go up to 1/1000th of a millimeter if you're using raw NC code. If you press the view button, it's going to move forward like this. So this is useful when you finish milling and you want to move your finished board forward to pick it up. And these other buttons we're going to use in order to set the X, Y, and Z origins. With this machine, we have to do it manually. Then we need to make sure that we have the correct things set up. So we don't want to use NC code in this scenario because the files that we have generated are actually RML1 formatted files. We want units to have as millimeters. Hit OK. And you see that here it changed to machine coordinate system, but we need to actually select the user coordinate system. So yeah, double check these things. So we need to be on user coordinate system over here. So we need to set the origin point according to the user coordinate system. And these we can leave as is, so 100% spindle speed, and as the feed speed, and then spindle speed also 100%. So with this machine, it's interesting that the spindle spins faster than specified in the specification. In specification, it's 7,000 revolutions per minute, but this spins up to 9,000, which is good. But it seems also that it causes a little bit of vibration, but just sound-wise, not really too bad of vibration. But okay, so in order to start cutting, we need to first attach the material that we're going to cut. So we are going to use this copper covered clad with 1.6 millimeter thickness, and I attached a double-sided tape on the other side over here. I'm going to open this up and make sure that this is clean. Snaps well in the bottom. Build platform. Okay. Then I'm gonna get the new PCB bits. So new, because like these are a bit different than the ones in the fab inventory, but with these you can actually go faster, and they are a bit more precise somehow. But yeah, so we're gonna start with the first one, which is the 0.2 to 0.5 millimeter milling bit, but we are treating it as 0.4 as the equivalent for the 0.4 milling bit. So we're gonna load that. In order to do that, you will need also this Allen key in order to open up this set screw over here. Yeah. And the collet should be inside already there. So it's the 3.175 or 135.1, I don't remember exactly. But yeah, from these we have to choose the 0.2 to 0.5 milling bit. It's gonna have a sharp tip, a V bit. And I am going to insert it into the collet like this. And you should go as deep as possible at first, and then we're gonna release it later. So yes, set the set screw, and then we can use the V panel in order to move the tool to where we would like to set the Z axis, the Z origin. So be careful with the Z movement, do not crash the tool into the material. So this place is relatively good for the Z setting. So in order to set that, move slowly downwards. So it is important to watch this distance over here in between these two elements. So it has to be enough distance between those so that actually the top part, so the top, so the Z axis can move downwards, because we want to cut into the material. And if it's not going to be able to move downwards, it means that it's not going to be able to cut into the material. And at the same time, we need to watch the distance between the tool head, the tip of the tool, and the material. So we want to move as close as possible, not too close, but at the same time leaving a gap over here. So I'm going to move 1 millimeter more. So I think this is a good gap. And now in order to set the Z of the tip of the tool, we will release the tool so it falls down onto the material by releasing the set screw. So now it's released, and now when it hits the surface of the material, we'll close, adjust the set screw again, and go back to the V panel. So SRM-20 vPanel interface and hit this set button over here. And vPanel is going to give me a message. This will change set origin settings. Should I continue? And yes, we want to continue. And you see that the Z was set to 0. Now I can lift it up a few millimeters in order to proceed with XY movement. So now we need to move it to a desired location where we would like to set our XY origin. This looks good. And to confirm that, we need to press this XY button over here. Do we want to change the XY origin? Yes, we want. And that's done. Now we can close the lid. And we can go to Cut, delete all, and go to the folder where we have our toolpaths. Then go to Milling. Nothing is going to show up because I mentioned in the previous video that the file format that CopperCAM generates is it's not really compatible with the... No, it's compatible, but it's not really what the SRM-20, so what the Roland software would expect. So that's why we need to select all files. And we can choose the engraving option. Hit open. And then output. It's going to start spinning. And the problem here is that the G-code has been generated by taking into account the spindle speed that has been set into the CopperCAM settings. And the SRM-20 software doesn't understand that, and that's why it throws this error. But we can just hit resume. And it's going to start milling. So now we finished milling the traces, and we can use the view button in order to move the board forward. We can open the lid. And let's use the vacuum cleaner to clean it. Looking nice. And now we can move on to the first drilling part. So in order to do the drilling, we will need to change the tool and also do the Z calibration. So let's start with changing the tool. So we're gonna choose one of the tools from this box. So we're gonna continue with 1mm holes. So we're gonna take the 1mm drill. Before we add that to the process, we're gonna remove the 0.41. I'm going to put it back into its box. So make sure that you put things back where they should be so that other people can find them easily after you use them. Then the same process has to be done here. So you first start by inserting the tool a little bit higher into the tool holder, and then so don't forget about a set screw, and then move the tool bit to a location where you want to set the Z origin. So where there's flat surface, somewhere here. Don't overdo with the Z motion. And again, the same principle applies. So drills are usually a bit longer, so you don't have to worry so much about the distance in between these two, so between the Z axis and its limiting structure. And at this point you can release the tool, so it drops and touches the surface. And now you should hit the Z button in order to calibrate in order to set the Z origin. Hit yes. Now we can move a little bit up. And we don't need to set the XY origin because it's already set, and we want the next process to use the same coordinate system, the same Z, so the same X and Y origin as the as the one for the traces. So we can close this down now and go to cut and delete all, select add. We need to show all in order to make the drill toolpaths visible, and I'm going to select the drilling 1mm toolpath and hit open and output. And again, it's going to show us the error message, and we just need to hit resume. And we're done. So I'm going to hit the view button and open the lid and use the vacuum cleaner again. And we can move on to the next drilling operation, and this time we're going to install the 1.5mm drill, which you can find here in the new PCB bits. Probably I'm gonna just gonna make it so that I'm gonna build a full collection in one box with all the diameters of the milling bits. So, but the 1.5 one is here. That's one with the green stopper rings, and you can see also the size on the stopper ring. So here, 1.5mm. I'm gonna put it here. I'm gonna remove the previous one. Put it back in the box, like so. Oh man, yeah, don't do that. Then insert it up until the stopper ring. Close the set screw, and then use the interface to move it to a location where there's a flat area where you can do the Z calibration, like so. I think this is also an alright height. I'm gonna maybe move it a bit more to the left and closer. And then again, I'm gonna loosen the set screw, let the tool fall down on the surface, and hit the Z button to set the Z axis. Yes, I want that. And lift it a little bit. Close the lid and go to cut, delete all, add, show all, and 1.5mm. Now it's gonna show me the error message again. Yes, and I just hit resume. Alright, we're done, and now I can hit view again. I'm gonna open the lid and use the vacuum cleaner again. And now I'm gonna install the last 2mm tool for the last drilling operation for the 2mm holes. I'm gonna put this back where it belongs. In the same sequence here, put it a bit deeper first. And move it to a location. And release the tool so that it hits the surface. Yeah, and now hit the Z button to set the Z axis again. And move a few millimeters up. Close the lid. And run the last drilling operation. Cut, delete all, add, show all, and drilling 2mm. Open, output. It's going to show us the message again. Resume. And remove the 2mm tool. And install the 1mm cutting tool. It's going to be this one. The 1mm flat end cutting tool. I'm gonna insert it up until the stopper ring, but I'm gonna move it a bit closer here. And here again, it's important to watch. So this time it's important to again watch the distance over here between the Z-axis bearings and the frame, because we want the tool actually to be able to go 2 millimeters through the material. So at this point, I'm going to release the set screw so that the tool drops to the surface of the material, like so. Now it's touching the surface of the material. I'm going to hit set. Yes. And lift it. Don't remember to set the set screw. Closing the lid. Now I can go to cut, delete all, add, show all, and the cutting 1 millimeter. Okay, output. It's gonna show us the message again. Resume. Now I can hit view. Open the lid and clean up. And once it's done, of course we are curious and we want to take out the board and take a look whether it was successful. So let's try to deattach it carefully. Oh, it seems that it cut like exactly 1.6 millimeters through. That's the board with all the holes. And remember to clean up after yourself. And that's it. So thanks for watching, and we're gonna continue with some videos about how to do double-sided milling. Thanks for watching.